Okay, so let us look at a couple of probability problems. So for the first one, it is for each of the following Venn diagram. So write the set denoted by the shaded area. Noticing that for this type of questions, the answer is not unique. For example, what you can think of is, what we can do is, because this part, which is the A minus B, right? And then for this part, which is B minus A. So you can think about it as A minus B union B minus A. So that's one option. Also, you can think about it as A union B, right, which is over all of those two. And then minus, this part, which is exactly A intersect B. Okay. So yeah. And for part B here, clearly you see that this is B and this part is C. So at the lines we do a B minus C and then we don't, right? And then part 3, as you can see here, is this pieces we can view as this part, which is A intersect C, right? And then union this pieces, right? Union the A intersect B. Okay, so yeah, so that's the first one, very straightforward. Okay. So now let's look at another question here. And this question says this. So let A and B be two events such that PA equals 0.4, PB equals 0.7, and then on top of that, PA union B equals 0.9. Okay. So the first part it asks us, okay, find P of A intersect B. Well, we know that based on the inclusive-exclusive principle, so PA union B equals PA plus PB, right, minus PA intersect B. So A union B is 0.9 equals 0.4 plus 0.7 minus PA intersect B. So it turns out easily you can figure out PA intersect B equals 0.2. Okay, so that's very simple to do that. And P part B, so we are looking for P A complement intersect B. And then if you draw a Venn diagram about the A complement intersect B here, suppose this is A, this is B. So A complement is this part, right? And intersect B, do you agree it's this part? So in other words, A complement intersect B is equivalent as B minus A. Okay, B minus A. So to calculate this is equivalent to calculate B, P of B minus A. And also noticing that B minus A we can also view as B minus A intersect B. Okay, A intersect B. So what we can do here is PB minus P of A intersect B. And then our PB, we know that, which is 0.7, PA intersect B is 0.2, so it's 0.7 minus 0.2, which give us is 0.5. Okay. And also, you see, for this problem B, the other alternative way you can think about it is, this is A, this is B. Okay. So PA intercept B here, this is 0.2, right? This is 0.2. And then PA is 0.4, so this part, do you agree, this is 0.2. And since P of B is 0.7 here, so do you agree the probability for this part is 0.5? And then the other part, since the universal set, the total probability should be 1. So we got 0.2 plus 0.2 plus 0.5, that's 0.9. So outside of this part is 0.1. So PA complement intersect B, which is exactly this part, as we display here. You can also read that it's 0.5. So it's just simple. Okay. And C, PA minus B, as you can read from here, is equal to 0.2. Okay. And D, P of, what is the P of A complement minus B? So it's P A complement minus B. So A complement here is right here, and then minus B here. And then noticing that, okay, so this problem really shows like the importance of the Venn diagram. So this is A, this is B, okay. And the A complement is this piece is here, minus B. So it's going to be so this refers to A complement minus B. So don't you agree that it is also equals to the universal set minus A unit B, right? A unit B. So based on the readout, we can see that this equals to 0.1. Of course, you can think about it as P S minus P A unit B, which we know that this is 1 minus 0.9, which also gives you its 0.1. Okay, that's part D. Part E, it asks us the probability of A in complement union B. So PA complement union B here, which you see the A complement union B here, and then as you can see, this is gonna equal to P A complement plus PB, and then minus P A complement intersect B. So because we are using the inclusive-exclusive principle, okay? And now for this part, A complement intersect B, we already figured out from part B here, okay? And PA, so PA complement is 1 minus PA, okay? So plus PB minus PA complement intersect B. So 1 minus 0.4 plus 0.7 minus 0.5, and then turns out this equals 0.8. Okay, this equals 0.8. Okay, cool. So that's problem E. Alright, so F, let's maybe write it here. Looking for the probability of A intersected B union a complement, we can use the distributive law. This is going to equal to P of A intersected B, right, union A intersected A complement, right? But you know that the A intersect is A complement. This part is empty set. So any set union its empty set, it's still itself. So it's just a P of A intersect B. And then we already know P intersect B from part A, which equals to 0.2. Okay, 0.2. So yeah, so that's problem 2. Okay. All right. Problem 3. It said that we consider a random experiment with a sample space S equals 1, 2, 3, etc. Suppose that we know P of K equals it's the event K equals C over 3 to the power K. K is from 1 to 2 to 3, etc. Okay, so that's the question here. So the problem asks us is what is the value of C, and on top of that, what is the P of 2, 4, 6, and which is all the even numbers, right? And is also what is the value for the P of 3, 4, 5, which is not the even one, but you know, one thing what we can do is, you see this set, its complement do agree just a 1 and 2, right? That's something we can think about it. Oh, I apologize. So for the second one is 2, 4, 6 is only 3 elements in this set. Okay, so we can think about this. So notice that, how do we find C here? So remember the exons of the probability, that is the sum of the probability P of K must be 1, right? So based on that, we know that you know, it's a C over 3 plus C over 3 squared plus C over 3 cubed, dot, 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 it equals 1. And this is a geometric series, right, with a common ratio, which is 1 over 3 here, right? So if we factor this C out, so it's a C times 1/3 plus 1 over 3, dot, 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 equals 1. So we know that a geometric series with this common ratio is you know, it's less between 0 and 1. So we're good to go. It converges, and the sum of this geometric series is it's the first term over 1 minus the common ratio, right? Is equals 1. So it turns out that this part, the 1 over 3 over 2 over 3, so it turns out this is 1 over 2. So C times 1 over 2 equals 1, so we can easily figure out that C equals 2, because C equals 2. And B, so find the probability of 2, 4, and 6. Okay. So since those are the events or disjoint, in other words, happen 2 cannot happen 4, so we know that this is going to be P2 plus P4 plus P6, which is 2 over 3 squared plus 2 over 3 to the power 4 plus 2 over 3 to the power 6, right? And yeah, you can write like that. That's fine. Part C, he asks us to find the probability of 3, 4, 5, blah, 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 blah. So what we can do is we can let it 1 minus the probability of 1 and 2, right? Use as the complement here. So as you can see, so 1 minus 2 times 1 over 3 plus 1 over 3 squared. So it's 1 minus 2, so it's 3 over 9 plus 3, right? So this is a 4 over 9 times 2 is 8 over 9 plus 1 over 9. Okay, that's the first 3 part. Very simple. So I'll stop here for this one, and then I'll talk about it in the next video. Okay. Thanks.